Thank you. I yes, in yesterday's session, should probably just go through a recap of that. So previously on C++ Online, I scared the living daylights out of everyone because I said that some things about CPP reference, and then I clarified that you can still use CPP reference. So we're not going to go through all of that again. But what I do want to cover is that I talked about the stood pairs piecewise constructor and how there was a mandates paragraph that meant that you couldn't use requires, you had to use a static assert. And a few people afterwards asked me some questions that about they thought that requires was a new keyword that they should be using, and am I saying that we shouldn't be using static assert? So we shouldn't be using requires, we should be still using static assert. And so, like, if I figured that if one person has a question, then multiple people probably think it. If two people are asking me, then that does mean that maybe something does need to be clarified. So here we are. In the standard, there are a handful, or there are many things known as words of power. These are regular words in the English language that the standard gives some sort of special meaning to, provides them with a definition. And some examples include things like the word mandates, the word preconditions. There's a long list of them, and I probably wouldn't be able to fit them all on this slide, even if I tried. So I'm just going to go through two of them in this lightning talk. The first one is mandates, which is the one that we've seen in the standard ease when I contrasted the standard ease against the CPP reference page. And that the definition for that is that if the conditions aren't met, then the program is ill-formed, or in other words, doesn't compile. And then there's also an example that talks about how you can use a static assert to get this sort of thing, or if you can get the overload set to behave as you want it, then you could use a requires expression for this particular constructor. I don't know if that's possible, so I stuck with the static assert. In the paragraph immediately above the mandates description, we have something called constraints. And this is similar, except that it says that in order for the function to participate in overload resolution, the conditions need to be true. And this basically means that that you can use a requires clause or spin-A if you're not operating in C++20. And so we'll go through two examples, both translating standard ease to C++, and that will hopefully give you a better idea of when mandates, so when to use static assert and when to use requires in implementing standard things. And then I'll very, very briefly go over why when you should be using requires and when static assert may be more appropriate. So here is the standard ease that we've seen 3 or 4 times at this point, and it has a mandates. And so the constructor that we have here, if we wanted to have a clearer diagnostic than just having this overload fail because of the attempt to construct first and second, we would use static asserts because it corresponds to the mandates paragraph in the standard. However, there is a conversion assignment operator instant pair that has a constraints paragraph. And so with this particular overload, we're able to use a requires expression, so a requires clause. And so that's what I put here. Now, I didn't pull this from any of the implementations. They do use spin-A for backwards compatibility reasons. So it might be slightly off, but I'm fairly confident that this is a conforming implementation of the constructor, at least for the purposes of a lightning talk. And now you might be wondering, well, okay, that's great. So you've got these two tools. Like sometimes the standard says constraints, and I can use requires for that. And sometimes it says mandates, and I can use static assert for that. But what about my code? Like when should I be using them? And my advice here is to kind of use your intuition. If you want things to not be in the overload set, then use requires. So that way, when the conditions fail, it's removed from the overload set. And if you have something that's a little bit more esoteric and you don't want it to be excluded, but you still want to impose some rules on the interface, use static assert or something that still keeps it in the interface but doesn't exclude it from the overload set. And that's pretty much it. I just want to remind you that we are a friendly bunch and are always looking for new people to join us. So if you're interested in learning how to contribute to one of the implementations, please do reach out, and I can help you point you in the right direction and even offer some tips for one of the implementations. Thank you.